Trigonometry Sokatoa. This is a mnemonic used to remember the three most important trigonometric ratios. Along with that, we can either use silly old Harry caught a herring trolling off America, or saddle our horses, canter away happily to other adventures. We'll see how to use these to remember the trigonometric ratios. Before that, we will look into what trigonometry and what are these ratios. Trigonometry is a word that got derived from three different words. Tri means three, gono means sides, metric means measure. So it gives a relationship between the sides and angles of a triangle. Now, with the help of these concepts, in olden days, they used to measure the distance of stars or planets from Earth. Also, most of the technologically advanced methods used in engineering and physical sciences are based on trigonometrical concepts. With the knowledge of this trigonometry, we would be able to answer questions like what is the height of a tree, a building, or a pole without actually measuring it. Also, looking from the top of a building, we would be able to tell at what distance a particular object is present just from the top of the building itself. Not only that, we can also be able to tell what's the height at which a hot air balloon is flying or a aeroplane or a bird is flying. For these concepts will be covered in later videos. We will look into the basics of trigonometry now. In trigonometry, we have got six different types of ratios. For that, here, if we observe these figures, we can see that all these have triangles involved and they make an angle of 90 degrees. So, these concepts require knowledge of right angle triangle. The right angle triangle has got few elements. Let us look into that. Apart from the 90 degrees, there are two other angles which would be acute. That is angle A and angle C. Now we'll take angle A as a basis, and for that angle A, BC would be the opposite side and AB would be the adjacent side. Along with that, AC is the hypotenuse. The first ratio is sine of angle A can be written as sine A also. This value is related to sides as sine A equal to opposite side upon hypotenuse. Here opposite side is BC upon hypotenuse is AC. Now, this ABC triangle is just taken as a reference. The notation of triangle would differ when we take, say, PQ or something else. So, the basic thing we have to remember is sine A value is equal to opposite upon hypotenuse. The next ratio is cosine of angle A or cos A. This would be equal to adjacent upon hypotenuse. Adjacent is AB upon AC. The next one is tangent of angle A or tan A. It is equal to opposite upon adjacent. Opposite is BC upon adjacent is AB. These three ratios like sin A, cos A and tan A are important. Along with this, the three other ratios are cosecant A or cosec A or CSCA. So these are the two different ways of writing cosecant A. It is equal to hypotenuse upon opposite, means AC upon BC. Next is the secant of angle A or sec A. This is equal to hypotenuse upon adjacent, means AC upon AB here. And the last one here is cotangent A or cot A. This will be equal to adjacent upon opposite, that is AB upon BC. These are the six ratios we have. So sin A, cos A, tan A, cosecant A, secant A, and cot A. Now these ratios are also related to one another. Let us see that. Now if we take sin A, it is opposite upon hypotenuse, whereas cosecant A is hypotenuse upon opposite. We can observe here that cosecant A is reciprocal of sin A. So we can write sin A is equal to 1 by cosecant A. The next value is cos A, that is equal to adjacent upon hypotenuse. And sec A is equal to hypotenuse upon adjacent. Again, sec A is reciprocal of cos A. So we can write as cos A equal to 1 by sec A, or sec A is equal to 1 by cos A. The next thing is tan A. Tan A equal to opposite upon adjacent, and cot A is equal to adjacent upon opposite. Tan A and cot A are reciprocal to each other. That is, tan A equal to 1 by cot A, or cot A is equal to 1 by tan A. Now observe this tan A value opposite upon adjacent. Now if we divide both numerator and denominator with hypotenuse, it will get modified like this. In the numerator we have opposite upon hypotenuse. Opposite upon hypotenuse is nothing but sin A, and adjacent upon hypotenuse is nothing but cos A. So tan A can be written as sin A upon cos A. Now the cot A is just a reciprocal of tan A, means adjacent upon opposite. Here also, if we divide both numerator and denominator with hypotenuse, the numerator adjacent upon hypotenuse can be written as cos A, and denominator opposite upon hypotenuse can be written as sin A. So cot A can be written as cos A upon sin A. Now we have seen the relationships between all the ratios here. We will see what SOHCAHTOA is. SOHCAHTOA is a mnemonic. The first SOH is for sin A equal to opposite upon H. Here we have taken the first letter from sin, that is S, equal to opposite, so O here, upon hypotenuse, H from hypotenuse. So SOH here means the value of sine. And the next thing is CAH. This represents for cosine value, means cos value. Cos C here equal to adjacent upon hypotenuse. A for adjacent, H for hypotenuse. So this CAH is for cos value. And the last one TOA. This is for tangent value, means tan value. Tan A is equal to opposite upon adjacent. O from opposite and A from adjacent makes TOA. So SOH is for sine, CAH is for cos, TOA is for tan. So SOHCAHTOA is a mnemonic to remember these three ratios. Along with this, we have two other ways of remembering this. The first one is saddle our horses, canter away happily to other adventures. The first SOH is for sign, saddle our horses, canter away happily, CAH is for cause, to other adventures, TOA is for tan value. Or we can also use silly old Harry caught a herring trolling off America. Here again we can see that SOH from silly old Harry is for sign value, caught a herring, CAH here is for cos value, trolling off America, TOA is for tan value. So these mnemonics would be handy to remember the ratios. And the rest of the three ratios can be obtained with sine, cot and tan ratios. We already have seen that sine of any angle is equal to 1 by cosecant, cos is equal to 1 by secant, and tan is equal to 1 by cot. In this video, we have seen the trigonometric ratios for an acute angle in a right angle triangle. and we have seen the relationship between the angle and the length of its sides.